Hey everyone, this is Chiranjeevi, and in today's video we are going to talk about the mediator design pattern. So let's start by taking a look at the definition. So the mediator design pattern is a behavioral design pattern that lets you define an object that encapsulates relations between a set of objects to make them independent of each other. So now the best way to visualize the mediator pattern is to look at this diagram. So now you see that there is a guy standing between these two guys and they are about to do some fighting or communicating or whatever is it, but this guy is like, okay, whatever you want to communicate with each other, you have to go through me. So this is what the mediator pattern also tries to say. So if you take a look at the mediator pattern's UML diagram, we have a mediator interface which is extended by concrete mediator, and all this concrete mediator has a reference to a concrete colleague and a concrete colleague too. Now if you take a look at this diagram, this guy in the between is the mediator between these two colleagues. So these two colleagues can be represented as a colleague abstraction and then be extended by a concrete colleague 1 and concrete colleague 2. So now if you see here, every colleague has a reference to a mediator and every concrete mediator has a reference to all the colleagues present in the system. So this is a pretty straightforward design pattern. So a mediator design pattern basically what it is trying to say is every communications happens through the mediator. So all the communicating parties need to contact each other using the mediator reference. So that's why our both concrete colleagues need a reference to a mediator, which they will get via this colleague interface, and the mediator is the one which knows both of them. So if colleague 1 asks mediator to send his message to colleague B, mediator knows colleague A and colleague B both. That's why this concrete mediator is having reference to both of them. So concrete mediator has a reference to concrete colleague 1 and concrete mediator also has a reference to concrete colleague 2. So this is all the theory for the mediator design pattern. I hope you have understood it. Let's go through a small coding example which will visualize this UML diagram. So I have created some classes which represent the entities participating in this mediator design pattern. So the first method which we are going to define here is the notify method. So we need to notify the colleagues in the ecosystem that there is a change. So for this, what I will be taking is a component reference, which is the reference for the sender and the message it wants to send. So this is a contract for sending a message in the system. So a sender of the message will call notify on the mediator, and the mediator will transfer the message from this component A to component B. So now in my system, what I am doing is I have a mediator which mediates between two colleagues which wants to contact with each other. So the second method what I am going to define here is the register method. So the mediator needs to be registered for all the communicating parties it is trying to mediate in between. So we need a component reference here. So this register method will take a component reference, and this mediator, whatever class is implementing this mediator interface, will provide an implementation for the registration method for a component. So this is the overall design for this mediator interface. Now let's go to one of our abstract component class and let's try to define the methods over here. So let's have a name for the component, which I will represent by a private string name, and also have a mediator reference. So for this mediator reference, we need also to access it from the subclasses. So we will define a protected mediator reference. So protected mediator. Now in the constructor for this, what I want to check here is we need a name and a mediator. So we'll quickly go ahead and create a constructor which takes a name and a mediator. In the constructor body, I'll quickly set this mediator reference, what we are passing, and also the name. So now we have our constructor ready. Now To send message from one part to other part, we need to define a contract again. So for this, we will be needing a public abstract method, which we will call send. So now this send method will be responsible for sending or communicating with the mediator. So whenever a component wants to communicate with another component, it will need to define this send method, and inside this send method it will be delegating the call to mediator, and the mediator will know how to handle the message from a particular component and how to route these messages. Let's also have a receive method, which mediator will call on this when the mediator wants to actually send a message to this component. So if you want to send a message from a component to a mediator, we use the send method, and if we want to send a message from mediator to a component, we use the receive method. So receive. Now this method also takes the incoming message as the argument. Let's have a small getter for getting the name for the component we are in. So this will simply return the name of the current component. Now we are ready with the component abstract class, which has a name and a mediator reference. So you can see in the UML diagram that this component is nothing but this colleague, which has a mediator reference and which is again an interface. So now let's go ahead to our component subclasses, which is component A and component B, and start providing the implementation for these abstract methods. So let's first go to component A and quickly implement the methods we have provided as abstract in the base class. So before that, I would also have to provide a default constructor. So let's go ahead and create a constructor for component A. And since we know that this constructor takes 2 arguments, but for convenience, what we can do here is we can restrict it to 1 argument and send the other argument internally. So let's take a mediator reference, but for sending the name, what we can do is we can hardcode the name to component A and pass the mediator reference. So that's it with the constructor. Let's add the definition for the send method. So let's hardcode the message for now, which component A will be sending to component B, and let's say I am good. Okay, so this is the method which component A is trying to send to component B. So let's have a simple logging here which logs to console that component A is trying to send a message. So let's go ahead and do a print line and say A is sending. And what is A trying to send? And this message is what A is trying to send. Now, along with what A is sending, in the send method, I said that we need to delegate the call to the mediator. So what we will say is this dot mediator dot notify, and in the notify I will pass this reference denoting that this is the sender which wants to send the message and the actual message itself. So this is the contract which these components are following to send and receive messages from each other. Now in the receive method, what I want to do is just a simple logging statement which will log to console that component A got whatever message was sent by the mediator. So this is it with the component A. Now let's go ahead and try to do the same thing for component B. So let's go ahead and implement the methods for component B, and this will be pretty simple and straightforward like component A. So let's copy the constructor from component A and change the name to B, and similarly here also. The send method here will also be same. So let's go ahead and copy this from here and paste this in B. But for the sake of differentiating it, let's rename the message part. So hey, what up? So now component B is sending hey, what's up? And The other things are also same, and for the receive part, let's also add this same logging statement over here, but instead of saying component A, let's say component B. So this is what component B definition looks like, and now we'll go ahead in our actual concrete mediator and try to implement that. So since this is implementing the mediator class, we need to provide the definitions for all the methods it has. Now, this mediator will also have methods to react on. So whenever there is a notification from component A and component B, this mediator will have special handler methods for each of the components. So before moving ahead, let's create some constants for the component names. So let's call it component A equals, and let's add the component A name here. Similarly, let's copy this and also add this for component B. So this is component B. Now we need to maintain a list of concrete colleagues, right? So as you can see also that in the UML diagram, we have a list of colleagues reference. So for storing the colleague reference, what I would like to do is I would like to create a map of string and component, where the string is the name of the component. So let's quickly go ahead and create a new hash map for this, and this will be instantiated when the new object will be created. So now let's go to the notify and register method. So before doing that, I said that we will have special handler methods for handling the notifications from both of the components. So since we have two components, let's add two methods to react. So let's call it react on A, and similarly let's add a method for B. We say react on B. Now whenever there is a reaction, let's print a small logging statement so that we can see at runtime that mediator is in action. So let's type mediator is in action. Similarly, we will need the same logging for react on B as well. Now what react on A does is whenever there is a notification from A, the system is designed to send the notification to the other component, and that's what it does for now. So the mediator takes the message from A, does some processing, which you can assume it like this logging statement, and then directs that message to B. So we will say whatever the map of components we have, from that map get the component whose name is component B, and then call the receive method on that with the message. So now we also need the message here, so let's add the message argument and pass this message over here. Similarly, for react on B, the same thing needs to happen, but with component A, and we also need to pass the message. So whenever B is sending a message or sending a notification, what the mediator does, it passes the message on to A. On the other hand, when A is trying to send the message, the mediator delegates the call to component B. So now let's go ahead and define this register method. So in this register method, we just have to add this component. So we'll just say component dot get name and the component itself. So now we can have a hash map of all the components this mediator is trying to manage. Now the last part is the notification part, where the mediator actually does what it is designed to do. So let's go ahead and get the sender name from this argument. So sender name is sender.getName. Now based on this sender name, if the sender name equals component A's name, we say react on A and pass this message. Else if component B equals the sender name, we call react on B with the same message. So this is the delegation part which this mediator is trying to perform. So now to see this in action, we need to go to the main class and actually create a small demo out of it. So let's quickly go to the main class and do it. So this is the main class, and to actually show you the demo, let's go ahead and start by creating a mediator. So let's name our mediator mediator. Now, since the mediator is in place, we need to create the communicating entities. So we need to create the components. So component A is new component A, and this takes a mediator reference. So component A knows that his mediator is this mediator. So whatever component A wants to communicate, he will communicate using this mediator reference. Similarly, let's create a component B which also takes this same mediator reference. So now we have tagged this component A and component B with the same mediator. Now, similarly, we also need to register these components for the mediator. So the mediator also knows that it has two entities to manage. So we'll do that by calling the register method on the mediator. Now, we need to call the register method for mediator for all the components it is trying to manage. So I am calling this register method on component A and component B. Now, whenever there is a component A wants to communicate or send a message, he will say send. And what this will do is this will ask the mediator to actually send this message to B. And since we have hard-coded this message, which is in component A's, I am good, so B will receive the same message. So now if we run this program, you will see that A sends a message, A logs it, then the mediator kicks in, mediator gets logged, and then the B receive gets called, which simply logs the message to the console. So you see A is trying to send a message, and when A is trying to send a message, the mediator kicks in because A is delegating the call to the mediator. Now it's mediator's responsibility to send the message to the correct person. So now this is a two-component system. It knows that if there is a message from A, it needs to send it to B. You can extend this common use case to any number of components you want. So to make this simple, I have only used two components over here. So now similarly, let's have a separator and try to send a message from B to A. So now if we run this program, we will see that B is trying to send a message and the mediator kicks in again and it delegates the message to component A. You see? Okay, so I think we have not modified the send method in B. So let's go here and yeah, so we need to name this B. So since this is a component B class, we want to send say that B is trying to send a message and not A. Now let's go ahead and run this program. So here B is trying to send a message, hey, what's up? And then the mediator kicks in and component A got the message. So this is what mediator pattern is trying to solve. Whenever there is a system of components which wants to interact with each other, but they don't want to be talking to each other directly, we will create a mediator between them which will actually take the calls from each of the object and delegate it to the correct object. And that's what mediator pattern is trying to do. So that's it with the mediator pattern. Let's go one more time with the definition. So mediator pattern is a behavioral design pattern that lets you define an object that encapsulates relation between a set of objects to make them independent of each other. And clearly you can see here that component A and component B are completely independent of each other. As long as they stick to the contract, no matter how component A and component B changes, the system remains unaffected. So that's it with the mediator design pattern. I hope you have understood this, and I hope to see you in the next one. Thank you.